This is the first of two videos in which I'm going to present solutions to aspects or elements of the first lab exercise from week 10. Over in eViews, I've opened up a work file, and you can see here that I have 2 pages. There's some data that we'll refer to for the second question, but right now we're interested in question 1. Looking at the series that are defined here, we're going to look at a model that has the quantity demanded of beer as the dependent variable, and then the price of beer, the price of other alcoholic beverages, and the price of all other goods, as well as income as explanatory variables. And the first thing that we're asked to do is actually estimate such a model, but using each of those variables in its log form. So we're going to transform each variable so that we take its natural logarithm. To estimate this equation in eViews, I'm going to choose Quick Estimate Equation, log Q. This is the log of quantity demanded or quantity consumed. This is going to be regressed on an intercept constant, the log of the price of beer, the log of the price of other alcoholic beverages, the log of the price of all other goods, and the log of income. Okay, I'll accept the default options there, and there's the estimated equation, and I will save this as model U. This is the unrestricted model. As this question progresses, we're going to impose some restrictions on the model. So right now this one is the unrestricted version. Part B says what factors should be considered before interpreting the estimated coefficients for this model. Very briefly, you should consider whether these coefficients here take the expected signs. In other words, if we think there's a direct relationship between the price of beer and the price of, and the quantity demanded of beer, this number should be positive. On the flip side, if we think there would be an inverse relationship, as the law of demand actually suggests, then it makes sense that this number here should be negative. That tells us that as price of beer goes up, the quantity demanded goes down, hence the negative sign. Not only do we want to look at these signs here, we also want to look at the t-test that is considered over here for each of the coefficients in the model, and specifically its slope coefficients that we're interested in. We want to check to see whether each of these variables is statistically significant, which will occur when the test of significance that it's conducted here is rejected, and that will occur when we have a very low p-value. So it looks like the price of beer, the price of all other goods, and income are statistically significant variables in explaining the quantity demanded of beer, but there's a question mark over the price of other alcoholic beverages in this model at least. Despite the fact that theory would suggest that a substitute good such as this should have an impact on the demand for beer. And also, just before interpreting the coefficients, it's also useful to look at the R-squared. This model seems to fit the data quite well with a high R-squared of 0.825. Part C will be covered in the written solutions. Part D says what are the F statistic and the associated p-value for the significance test associated with this estimated model. So the F statistic is this one here, 29.54377, and the probability associated with that, the p-value, is virtually 0. And what are the null and alternative hypotheses for this test? Well, I've got those shown in another document. This F-test of the significance of the model has as its null hypothesis this, that all of the slope coefficients are actually equal to 0. Note that it's only the slope coefficient, so I'm not hypothesizing that B1, the intercept coefficient, is equal to 0, but every other coefficient, B2, B3, B4, etc., up to however many variables we have in the model, are all equal to 0. If those slope coefficients are equal to 0, it tells us that the variable associated with that coefficient doesn't have any explanatory power in explaining the dependent variable. This test has as its alternative hypothesis that at least one of the slope coefficients is not equal to 0. Now, flipping back to the eViews output, and part 3 of part D asks us what conclusion will be drawn from this test. Well, we have an extremely low p-value, and this suggests that we should reject the null hypothesis. The null hypothesis, remember, was that the model was not significant in explaining the dependent variable, demand for beer. So here we will say there's strong evidence that the model is useful in explaining the demand for beer. On to part 4 of part D. We're asked now to show how this F statistic can be calculated in a variety of ways. The first one says, show how the F statistic can be calculated by conducting a Wold test. Now, this will be done, or one way of doing it in eViews is to go quick, and then, sorry, no, it's not quick. Having estimated the equation here, I am going to go to View, Coefficient Diagnostics, and then Wold test, Coefficient Restrictions. This F test that we're conducting has all of the coefficients, which are expressed here as C bracket 2 rather than B2 as we're accustomed to seeing it. It has those equal to, presumed equal to 0. So the first restriction is that B2 is equal to 0. For the next restriction, I put a comma and then a space and say C3 is equal to 0, C4 is equal to 0, and we actually have a fourth explanatory variable, which means a fifth regression coefficient when we also consider the intercept coefficient, and that one is assumed to be equal to 0. So there's the restrictions in my null hypothesis, that all of the slope coefficients are equal to 0. I now ask eViews to calculate, or to run that hypothesis test. Here's the output. If I want to save this, I need to freeze it first and then give it a name. I'll just say F-test 1, because we're going to look at doing this F-test in a variety of ways. Now, I'll just bring this over here, and then go back here to this equation and view it, the estimation output. So, originally we saw that the F statistic was equal to 29.54, and I have come up with the corresponding number using that Wold test approach. And the p-values are the same as well. Here we have 0.000, maybe one more 0, I'm not sure how many, and the same thing down here. So, we found one way in which that F-test can be conducted in eViews. I'll now move on to the second part. And for this one, in fact, no, I'll take up the second part and the remainder of this question in part 2.